All right, so here we are, chapter 1 in Math 9. We're going to talk about square roots and surface area. In this class, particularly, we're going to split chapter 1 up into two parts. So we're going to do kind of part 1 first, and then we'll do part 1 separately. We're going to focus on square roots here now, and of course, the name square roots has square in it. So squares are a pretty important part of square roots. So we're going to talk in 1.1 here about square roots and perfect squares. So you should have notes in front of you here. And what you'll learn is how to find square roots of fractions and decimals that are perfect squares. So we're not going to focus on just the whole numbers. We're going to focus on fractions and decimals as well. Okay? So there's going to be some patterns and some tricks that you're going to learn how to kind of work with perfect squares there. Okay, you're also going to learn how to approximate square roots of fractions and decimals that are not perfect squares. So some terms that you want to pay attention to as we move through the chapter. Square, okay, square root, perfect square, non-perfect square, terminating decimal, repeating decimal, and non-terminating, non-repeating decimal. So as we go through the lessons, I will explain what these terms mean, and good idea for you to come back to this first page in your notes and fill in the definitions kind of as we go along, or at the end of every day, make sure you have this filled in. This will be a good, some good study notes for you as well. And if you have any notes or questions for me, please write those down so that you can ask those in class. All right, so let's just talk real briefly about some basic stuff. Review from grade 8, okay, or from your previous learning. What is a perfect square? Okay, well, a perfect square, if you think about geometry, if you think about a perfect square is a shape, right, that has what? Talk to me about a square, the actual shape of a square. 4 sides, good. I'm sorry? Nine, what did you say? 90 degrees, yes. What about 90 degrees? Where's 90 degrees in that shape? 4 sides. 90 degrees would be what? The angle at every corner has to be exactly 90, right? It's not going to be bigger or not going to be smaller than 90, but you're right. So angles, the interior angles there have to be each 90 degrees. And what else about the side lengths of a square? They have to all be the same. Very good. Okay, so what is a perfect square? We can take a moment just to jot down some of those notes. So here's some notes on what a perfect square is like geometrically, right? What about a perfect square number? So this is going to be really important that we study and learn about what a perfect square number is. Maybe I'll just zoom in just a touch for you. Okay, what's a perfect square number? Someone mentioned when we were doing our little intro activity there. What's a perfect square number? Or I guess I asked about the square root is what we talked about, but a perfect square number, think about, okay, well, talk to me. What do you got? An idea? That's okay, we can refine it. Any idea? What's a perfect square number? A number that's a perfect square. We call this number a perfect square. What does that mean? Okay, so a perfect square number is a number where we actually have another number that's multiplied by itself exactly once to get that. So a perfect square number is the product, let's write this down, the product, so that means the result of multiplying, the product of now we're going to be pretty detailed with this definition, and I'm going to say a rational, okay, a rational number multiplied by itself. So the product of a rational number multiplied by itself. And I think we should talk a little bit more about rational. So a perfect square number is obviously the product of a whole number multiplied by itself, but a rational number encompasses more than just whole numbers, okay? So a rational number technically is any number that can be written as a ratio, because that's what the root of rational is. It's any number that can be written as a ratio of 2 integers. So integers would be positive or negative, like whole numbers, okay? And 0 0 can't be on the bottom, it can't be on the denominator, but that's only one case where that's a bit of a problem, right? We don't divide by 0 ever. That's a problem. I'll talk a little bit more about that later if you want to know. But so a rational number. So for example, 9 is a perfect square number because it is, and I guess I wrote that over here as my first example, because 9 is 3 times 3. So therefore 9 is a perfect square number and 3 is its factor. Okay? Now a factor would be one of the pieces of multiplication that multiply to another number. So if we're talking about rational numbers, guess what? We can move to other rational numbers too, and I can say something like, did you know that 4 over 16 is a perfect square number? Because that's going to be what? What rational number times itself will give me 4 over 16? So we're jumping ahead a little bit here, but I think you guys, probably some of you might know this. What times itself will give me a product of 4 over 16? Yeah, 2/4 or 2 over 4. Because 2 times 2 is 4. 4 times 4 is 16. Okay? Now what about this one? I'll give you one more before we move on with the notes here. This is another tough one. It's a fraction. So what is this a perfect square? 1 over 4. So do we have a rational that is a fraction or a whole number, integer, that can multiply by itself to get this one? Well, some of you, I think, are smiling a little bit, noticing that 4 over 16 is actually the same as 1 over 4. So 1 over 4 is just a simplified version of 1 over 16. So I have 1 over what? 2 multiplies by itself to get 1 over 4. Okay. All right, let's just back it up and go over some terms and some meanings. So you have some blanks in your notes there. So what is the square of 3? That's the question. The square of 3. Now when I say that, what I mean is, what is 3 times itself? Or you should remember maybe what this is. 3 to the power of 2 is actually 3 squared. So what's the square of 3? That is to say, if we have a side length of 3 and we make a square out of those side lengths, right? What is the square of 3? Well, the square of 3 would be represented by the area inside that square. So it's 3 times 3, or 9. Okay? Another way to put that is, what is 3 squared? That's another way to just say 3 to the power of 2. So that's 9 as well. And of course, another way you might hear me say that is, what is 3 to the power of 2? That is 3, the base, to the power of 2, the exponent. Okay? So each of these 3 ways, you can use those 3 ways to say the same thing, really. Yeah? Question? Oh, okay. I thought you had your hand up there. You just stretching? All right. Okay, any questions so far about this this is kind of review, I guess. Okay. All right, so let's keep going here in your notes here. Let's say we can sketch a diagram of a perfect square. Remember what a picture of a perfect square looks like that we talked about, by actually drawing squares, okay? And so the perfect square numbers can be represented by pictures of squares. So the factors, that is the number that is multiplied by itself, that's the factor, are the side lengths of the square, and the area is the perfect square number. So this is something you should be familiar with here as well. And I have this in your notes. Length times length of a square gives us the area of the square. So in the case where we have a side length of 3, and here's 1 unit, 2 units, 3 units, right? And we have another side length of 3, that makes a perfect square. And it would make sense that 3 times 3 is 9. And here you see the 9 little squares we have inside this picture. Okay? So 3 times 3 is 9. The area of a square with side length 3 is 3 squared, or 9. Okay? So there's 9 little squares in there. Okay? So 9 units. So the side length is 3. The factors are 3 and 3. These are also called factors. Okay? Now, what about perfect square numbers? Let's do some more work with perfect square numbers. We talked about this earlier. this is a good spot right here on your notes to write the list of perfect squares, perfect square numbers from 1. So 1 is a perfect square number because that's 1 squared is 1. 4 is a perfect square number because that's 2 times 2, and so on. Here's the diagram, there's the diagram. So what I'd like you to do is I'd like you to take a few moments. I'll get you started here, but we're going to list the perfect squares from 1 here all the way to 400. So we're going to go 3 squared is going to be next, which we know is 9. You do not have to draw all of these, but what you might want to just realize is that 3 squared equals 3 times 3 is 9. 4 squared is 4 times 4, which is 16. Okay, you guys help me out here now. Let's just go 5 squared is what? 25. That's 5 times 5 is 25. 6 squared is? Yeah, it's 6 times 6 or 36. Okay, 7 squared? 49. 8 squared and so on. So I'm going to let you guys go all the way till this number on the side here hits 400. Okay, so if this number on the right side hits 400, what am I going to be squaring at the very end of that? 20. Yeah, it's going to be 20 squared. Very good. Okay, so you guys take a few moments and you guys write down this list. Use your calculator if you need to, but try and work it through and see how many of these you remember. I'm going to write it on the board here as well and show you in a bit. All right, so here's your numbers. You should have these all the way up to 400, so it's going to be 20 squared is 400. So you should have these committed to memory. Please start to work on these. I think the tough ones will obviously be from 11 to 20, right? Memorizing these numbers, but you can do it. All right, so let's talk about the symbol for square root. Okay, so when we're talking about the square root, remember what we're talking about is what is the length of the side. If we have an area of 9 inside the square root is 3. If we have an area of 16, the square root is the side length of that square, which would be 4, and so on. So the square root is this little symbol right here. Okay, now it's a little bit different than the dividing symbol. So you may remember this, like if we had 12 divided by 4, okay? Those are very similar, but they're not the same, okay? Those are not the same. The square root clearly has this little thing on the front there, okay? So a square root has this little check mark on the front, really, and this is your divided sign, okay? So it has nothing right here. All right, so make sure you don't get those confused, and don't try and be cool and say, I'm going to make my square root sign without a little check at the front. Yes, because I'm cool. No, don't do that, because you'd be wrong. You might be cool to some, but you'll be wrong to me, which that's the big deal. Okay, so square root, like, and then a line on top. Now, this line on top really should extend over everything that you want to take the square root of. So, for example, that's thing that'll come later, but if you want to take the square root of, let's say, 225, your square root sign should start over here. It should go up over top of the letters, and then make sure it doesn't end there. Okay, that's not good, because if you want this whole number to be underneath, take the square root of this whole number, you have to extend that over. And some people actually do this a little bit of a at the end, to be sure. You don't have to, but some mathematicians, math students do that. So just make sure that it's over the entire number that you're meaning to take the square root of, because this root 2 times, this could be root 2 times 25, right? That's what that actually means if you don't extend that little sign. Okay, and these are not the same, of course. They're not the same. Okay, so the symbol is this little square root sign. We just call it the square root sign. And the meaning of it is, you know, we're trying to find the number that's multiplied by itself to give you the number underneath. So square root of 100 is 10, okay? And this little graphic right here, this just kind of helps you explain how we get 10, because 100 is made up of 10 times 10. So if you can write this number as a product of two identical factors, then that's the square root, and it is a perfect square. So what is this? This is, we would say this as the square root of 49, or you also could say, and you would be right, just say root 49. So if you just say, what's root 49? Root 49, Like I say, as you move in through high school math, you don't necessarily have to say square root when you just mean square root. You could say just root. So root 49 is how I often say that in upper level math. But for you, it is square root. Now, there are other things called cube roots and fourth roots and so on. But if you don't say anything in front of that root, then it's assumed to be a square root. So you would say square root of 49, or it wouldn't be wrong for you to say root 49, okay? Root 49. That's kind of the shorthand. So any questions here so far? All right, you guys are with me? All right, so this little chart here, let's start to fill in this little chart. Which square or square root are modeled by each diagram? Okay, so I have a picture here of a square, a large square, that has an area of 49 units, and the side length here looks to be 7 units high here. Okay, so the length squared is the area, right? So that is 7 squared is 49. So the area is 49 square units. Now this is going to be important too as we understand the square units. Okay, so if it's a perfect square number and you're referring to an area, the units are not just like centimeters, or the units are not just like, meters, but you have to have square units. So the area, if you might remember this from grade 8, but the area of something would be units, length units squared. So you'd actually have to have, like, if this was centimeters, it would be centimeters squared, 49 centimeters squared. So we'll talk more about that as we kind of move through. All right, so the square root is modeled by the root of the area is the length. So root 49 is 7. The unit side length of the side length is 7 units long. Okay, B, let's continue with this pattern here. So this is the square here. So length squared, so what's the length? It's tough to see on the screen, maybe that's 4. So 4 squared is going to be what? 16, okay? So the area is 16 square units, all right? And we can actually count those. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So the square root of 16 is 4. The square root of 16, the area, is the side length 4. All right, I'll give you a moment to complete C and D on your own, and then I'll show you what I got in a few moments. So go ahead and do C and D there. All right, so there's C and D filled out. Any questions about C and D there? The side length squared is the area. The square root of the area is the side length. Okay, here's another chart. Why don't you go ahead and we'll start doing this chart here as well. This should be pretty easy for us to work with. So make that a little bit bigger for you. Okay, so complete each sentence. I'll do the first sum with you here. So 1 squared means 1 times 1 is 1. The square root of 1 is 1. Okay. Number 2, 2 squared means 2 times 2 is 4. The square root of 4 is 2. So let's go ahead and fill in some blanks. 3 squared means 3 times 3, and that equals 9. The square root of 9 is 3. And this is very good repetition. You do this over and over. It will be ingrained in your head. You'll never forget it. So 4 squared, 4 times 4. That's 16. Therefore, square root of 16 is 4. 5 squared is 5 times 5, and that equals 25. Therefore, the square root of 25 is 5. 6 squared, 6 times 6 is 36. Therefore, the square root of 36 is 6. All right, you do the second row on your own. Get that practice in, and I'll show you what I got in a minute here. All right, so just double check your chart there. Make sure it lines up with this, or let me know if I've made any mistakes here, or if you have any questions. All right, everybody good? Okay, let's move to decimals, because decimals are the tricky part of this, okay? So let's finish off this lesson here, the first part of this lesson, with talking about the decimals. Okay, so first of all, if we have a decimal, let's practice making the decimal into fractions. And remember, we started off this lesson by talking about perfect square fractions or rationals. All right, so 0.6, remember the places, so your decimal places. So this would be tenths, right? Tenths. And then the next place would be what? Hundredths, right? Okay, so those are two important things to remember. The next place then would be thousandths. Okay, so if we have a 6 in the 10th spot, that's easy to write this as 6 tenths, or 6 over 10. What about this one? 8 is in the which spot? It's in the hundredth spot. So that's going to be 8 over 100. Very good. Now, we can simplify this. Do you remember how to simplify fractions? Yeah. Try and find a number that you can divide both the top and the bottom by, and then keep doing that until you can't find any number that you can divide both of them by. So I can divide both these by 2 for sure. That one I know off my head, that's 4 over 50. Okay? Now, can I do that same process again? Is there another number I can divide the top and bottom by evenly? Yeah, I could do 2 again, right? So divide by 2, and you guys know how to do this. So that's going to be 2 over 25. Now, is there another number other than 1 now that I can simplify this? No, not really. Okay. All right, what about 0.25? So if we have a number both in the tenths and the hundredth spot, we look at the very last spot that the numbers occupy, right? So this is the 100th spot. So that's 25 over 100. 25 100ths. And that simplifies to 1/4. Okay. What about this next one? 0.379. What fraction would that be? Okay, so we can write this number 379, and then I look at the last place here that the numbers occupy. That is the thousandths spot. So you'd write that as over 1,000. Okay, very good. So what you want to remember is this over here, the spots. So this is the 10th spot, the first one. 100th is the second spot after the decimal. And thousandth is the third spot there after the decimal. Any questions there? If not, let's get some practice here. So again, we're building up towards perfect squares of decimals and fractions. So let's just get some practice converting decimals to fractions. Here we go. 0.4 is 4 over 10, right. Now is that, yeah, simplest, let's practice our simplest forms. That's 2/5 or 2 over 5, very good. Let's go down the column here. This is 75 over 100, yeah. Can I simplify that one? I suppose I could, hey, divide both by 25 maybe. So I get 3 over 4, awesome. 5 over 10, or 1 over 2. 7 over 10 as well. Now, that one we can't, I mean, if we have to go to a decimal, it's no good. You don't want a decimal inside a fraction, okay? Don't put a decimal inside a fraction. That's not simplest form. This one, 333 over what? Tenths, hundredths, thousandths. Very good. All right, you do the last 3 on your own. Okay, so here's the last 3, and simplest form as well. I just wouldn't do that for the 333 over 1,000. Simplest form, you can go with that. All right, let's remember something, how to multiply fractions, moving on here. How to multiply fractions if you have something like 1/2 times 2/5, okay? Multiplying fractions. Do you have to get a common denominator when you multiply fractions? No, you don't. When you add or subtract, you do, but not when you multiply. All you do is you multiply the numbers on the top straight across, however many there are, multiply them all up. So 1 times 2 is 2. And then you write your little line there, so this line right here, and then you multiply the numbers on the bottom. Now this can simplify to 1 over 5. Okay? Now when we multiply, I actually would like to point this out. When you multiply, there is a step that you can do before you just go ahead and straight multiply. And I don't know how comfortable you are with this, but this will make multiplying fractions quite a bit easier if you, instead of simplifying at the end when the numbers potentially could be really big like this, you know, if you can simplify before that point. So watch this. 1/2 times 2/5. If you have like I could rewrite this because it's multiplication. I could actually go 2 over 2 times 1 over 5. You know that? Because 1 times 2 is exactly the same as 2 times 1. And what I noticed there is that 2 over 2 is actually just 1. So I've in essence, I've simplified before I multiplied. Now, if you don't like that, because you probably have never done that before, let me just show you this. This is the way I would do it. I would notice, hey, there's a 2 on the bottom in the denominator and a 2 in the numerator. And when you have 2 on the top and a 2 on the bottom, and they're both factors, they're part of this multiplication scheme on the top and the bottom, then you can simply divide those or simplify that as a separate fraction. So 2 over 2 is the same as 1 over 1. And now I get 1 times 1 is 1, and 1 times 5 is 5. So you can simplify before you multiply. That would be awesome if you can do it. So let me show you what I mean. This one, 1/5 times 1/3, you can't simplify top and bottom with any of these numbers, so we'll just go ahead and multiply. 1 times 1 is 1, and 5 times 3 is 15. There's our answer. Now, if I skip over to number 6, let me skip over to number 6. So you can do this two ways. You can go ahead and go 6 times 1 is 6, 10 times 2 is 20, and then simplify from here. You can divide both those by 2, and you get what? 3 over 10, and that looks like to be in simplest form. Now you could do it that way, or you could do it this way. You could notice that, hey, 6 on top as a multiplier and 2 on the bottom as a multiplier. I can actually simplify 6 divided by 2. That becomes 3 over 1. And now this becomes really easy to multiply. 3 times 1 is 3. And 10 times 1 is 10. All right, so this is the 1.1 assignment, page 11. You guys can, after this brief lesson, you can do number 1 to 3 for sure. So 1 to 3 for tomorrow, and then we'll continue on. Okay?